So let's just do a real quick verbal recap. We have position, which would be something like feet or meters or yards or miles. And then the derivative of position gives you velocity, which would be miles per hour or feet per second or, something per something else. It's a rate of change. Absolute value of velocity. Absolute value of velocity. Speed. The speedometer in your car does not go negative. So velocity is directional. Positive means you're going forwards or upwards or to the right. Negative means downwards. But speed is the absolute value. Speed is always positive. And then the second derivative is acceleration. So that would be like feet per second or feet per second squared. Okay, so it's a rate of change. So let's read what's going on here. Table below gives values for velocity and acceleration, particles moving. Remember, a particle can be anything with motion. It's not like a dust speck. It says velocity and acceleration are, that means they're also continuous. That's going to come up because we're going to write a justification here. So just as a heads up, all right? The velocity is decreasing. We can see that 5, 3, -1, -8. Use the data in the table to answer the questions. Is there a time when the particle is at rest? At rest means what? Velocity is 0, not moving. So let's look at just the velocities. Is there a time where that velocity would be 0? Yes or no? Just what do you think? Yes is the answer. There would be a time when velocity is 0. It would be in between which two times? And I'm looking for in between 0 and 2, in between 2 and 6, or in between 6 and 10. Those are kind of like your 3 options. Good. You all have common sense. Fantastic. We're going to have to write it out, but you're there. All right. Why did you say in between 2 and 6? 0's between those, and the function is continuous, which means you didn't have any gaps or holes or breaks or other problems. So we're going to take everything we just said there and try to put it into a concise sentence. All right. But in essence, it's yes. Velocity equals 0 between t equals 2 and t equals 6 because velocity is continuous. Because it was differentiable, we know it's also continuous. And you have to, in some capacity, say that 0 is between these other two numbers. So here's, I did teach this last year. I wonder if anyone is going to remember this. I think the shortest way to put it is -1, or you could even say v of 6. They'll like that better. Velocity at 6 is smaller than 0, which is smaller than velocity at 2. It's your intermediate value theorem. We teach the intermediate value theorem in pre-calculus, and then it comes up again in calculus. Since the function is continuous, we use it usually to show that there's a 0 in between two other numbers. Do you guys remember the thing we did up here where there was a graph and there were those bubbles and we guessed if there was a 0 behind them and then we moved them? Sort of. Anyway, that was our intermediate value theorem. Go ahead.
So would it still be considered correct if you put like instead of V6 and -1 less than 0?
Less than 3? Yeah, that's fine. Yeah, because those are equivalent things. Yeah. All right, so at letter B. Now this is not an interval, it's just at what time indicated in the table is the speed decreasing. Now when it's speeding up or slowing down, you have to look at both velocity and acceleration. So let's verbally review this. If they are the same sign, what does that mean? Speed is doing what? Speeding up, increasing. If they're opposite signs, like they're disagreeing with each other, decreasing. All right, so at what time, and so your choices are 0, 2, 6, and 10, is our velocity and acceleration opposite signs. At 2, do you see how this one's positive and this one's negative? I get a lot of times people bring this up. 0 is not positive or negative, so you can't use that. So we're going to say t equals 2 because v of 2 and a of 2 are opposite signs. And I hate to tell you, but if you just say are opposite, they won't give that to you because Saying two things are the complete opposite of each other means that one is 7 and the other is -7. Like, that's what that means. So you have to say opposite signs. And I get that that's hateful and picky, but I'm the messenger. All right. Number 5, this time we have a graph. Sometimes they give you a table, sometimes they give you a graph, sometimes they give you an equation. So you got to be able to use whatever they give you to answer the question. What is this the graph of? Position, velocity, or acceleration? Which one? Velocity. So this is already something per something else. Oh, and they even tell us meters per second is what we've got. Piecewise linear, they throw that vocabulary out there. Linear means line, piecewise means broken into pieces. Do you see how it's 3 lines broken into pieces? That's all that means. Don't let that, throw you off. All right, for each of these, find the derivative at 4 and the derivative at 20, or explain why it doesn't exist, include units of measure. I'm actually going to do the v prime of 20 first because that's the easier one. Like, we'll actually be able to get an answer for that. Derivative means slope. So here's 20. You're going to kind of just have to watch me point to it. Here's 20. We want the slope of this line. So it goes, down 20 and over from 16 to 24, 8. So down 20 over 8. It's exactly like algebra 1. We're literally covering slope in algebra 1 right now. It's like down how much and over how much. Now that'll reduce, we'll both divide by 4. So -5 over 2.
And that's not a linkage to it?
No. So if I had said v prime of t or x, that's a linkage error. But because I'm doing it at a specific number, that's what it equals. Now it says indicate units of measure. We did a derivative of velocity, so it's an acceleration. So it'll be meters per second squared. Good. So now, as a heads up, v prime of 4 does not exist, and we're going to use limits to explain why not. Limits from the left and limits from the right. But why is it does not exist at 4 in common sense terms? Sharp edge. Okay. So we're going to do the limit as t approaches 4 from the left, and the limit as t approaches 4 from the right. And it's a slope. Remember, y2 minus y1 over x2 minus x1. It's going to look like that. All right. So it's v of t minus v of 4 over t minus 4. And then you're going to literally just copy that again. That was back from unit 2. If you look back through that, that's where we did that. And so what is our slope from the left? The slope of this line. It's how much up and how much over did you go? We want the slope of this line. Up 20 over 4. So 5, I agree with that. And then what's the slope from the right? The slope of this one. It's 0. And the point is they don't equal each other. It's a lot of writing to explain that. I get that, but that's the justify part. Okay. But don't write anything beyond that. I don't want a paragraph. That's it. All right. Let a of t be the acceleration. Write a piecewise defined function. This sounds difficult, but it's actually pretty easy. And we did almost all of it already. How many pieces do you think are going to be in the piecewise function? 3. And derivative means slope. So if we're going from velocity to acceleration, that's a derivative. What did we say was the slope of the first piece? 5. And that goes from 0 to 4. I will write you class in just a second. Let me finish this problem. All right. And then the slope of the middle part was 0. And that is from 4 to 16. Good. And then we actually found this one already too. What's the slope of that last piece? Yep. -5/2. And that goes from 16 to 24. I know some of you are thinking this. Why don't any of those have equal to's on them? You can't get derivatives at these points because of the sharp edge. Okay, so yeah, this last one, an average rate of change just means a slope. So you want the 0.8 something and the 0.20 something. You'll just look at the graph to find them. So what was your point for 8? 8 is 20. Right here, 8, 20. And then 20 is 10, halfway in between there. And then you'll set it up 10 minus 20 over 20 minus 8. Try really hard not to do anything to that. But we do want units. And that was velocity, which was meters per second. So if you do a rate of change of that, it will be meters per second squared. Okay, so we're gonna just do a whole bunch more practice. So read number 1, were you given position, velocity, or acceleration? Position. Good. That's like honestly half the battle was what on earth did they give us and what on earth do they want from us, right? So they gave us position. We want speed increasing. That's a little bit of, work there. You want where velocity and acceleration are what? The same sign. Okay, either both positive or both negative. Well, first you have to find both of them, all right? So let's find velocity. So what is your velocity equation? Derivative of this, which would give us what? We've forgotten how to take a derivative. 4t squared, there we go. The 3's cancel. Minus 16t plus 12. Perfect. Now, if we're going to have to look at where that's positive and negative, I suggest setting it equal to 0. And then let's factor it and do the algebra and just go ahead and do all that right now. What will these all divide by? 4. So that would give you t squared minus 4t plus 3 equals 0. 0 divided by anything would still just be 0. And then we're going to split that up. So that would be t minus 1, t minus 3. So hold on to that for a minute, just because we're going to need to be able to figure out where it's positive and negative. So I went ahead and did that. So you'd get time 1 and time 3 is where the changes are going to happen. So now let's go and get our acceleration. So look back at your velocity, this right here. What's the derivative of that? Yeah, 8t minus 16. Good. And then that'll all divide by 8. So it would be t minus 2. Now, you can think through this however works best for your brain. I'm going to show you how I think through it, and then you can kind of take that as you will. I make a number line, and I put in the little pluses and minuses. It makes it visual for me, and then I can see it. If you don't want to do that, you technically don't have to, because they won't read a number line. They'll just read your answer and justification. But I'm just telling you, it helps to visually see it, so I'm going to show you how I do it. All right, I'm going to put velocity on one line, acceleration on another line. And if they give me a window, I'll put that on either end. Like if they say from times 0 to 8, I'll put 0 to 8 or whatever. This just says times bigger than 0. So we're just going to start at 0. Now, where did we get that velocity was going to change? 1 and 3. So I'm going to put 1 on there and 3. And where did we get that acceleration was going to change? At 2. And do you see how I put it 1, 2, 3? We actually do this in pre-calc as well, but yep, it's a lot of stuff in there. All right, so give me a number between 0 and 1. 1.5. You don't need to figure out what the number actually is, just if it's positive or negative. Do you remember above and below sea level? Literally just did this first block in pre-calc. All right, 1/2 minus 1, negative. 1/2 minus 3, negative. A negative times a negative, positive. So that section is positive. So give me a number between 0 and 3, between 1 and 3. 2. 2 minus 1, positive. 2 minus 3, negative. Positive times a negative is negative. And if you pick a number bigger than 3, like 4, plug into those, they're both positive. So now we're going to do acceleration. Give me a number between 0 and 2. 1. 1 minus 2 is negative. And if you pick a number bigger than 2, it's going to be positive. And then I separate it with these little like balloon strings. Now, last year we did what's the overall sign. That's not what we're doing here. We're just comparing, are they the same or are they opposite? So for this first section from 0 to 1, they're opposite. Oh, now I forgot. Did we want them to be opposite or did we want them to be the same? Okay, we want them to be the same. Okay, so not this section. From 1 to 2, they're the same. Okay, so we want that. From 2 to 3, no. And then from 3 onwards, yes. So we would say from 1 to 2, union 3 to infinity, because they didn't cap it. Because velocity and acceleration are what? Same sign. There was a lot of work for that one problem, and there was a lot of algebra in there. Again, they won't read your number lines. So if you can do it without that, more power to you. But yeah, that's my question is how would you do it without writing that? But some people like are geniuses in their brain and can just do stuff like that. I am not one of those people. I'm a concrete person. I need to be able to see it. So anyway, if you have this and not this, 100% full credit, but I don't know how you do it. So, all right. This one's going to be a calculator problem. I'm going to have you guys just watch along with me. 2 particles, so we're going to compare. Start out at the origin, move along the x-axis. This is your window, 0 to 10. Were you given position, velocity, or acceleration? They're both position. As a heads up, sometimes they'll make one of them be position and the other one be velocity for extra fun. So you got to like stay on your toes. All right, but these are both position. For how many values? So you don't have to find what they are, but just how many. Do they have the same velocity? So we're going to get the velocity of the first one, velocity of the second one. So those are derivatives. So what is velocity for the first one? Cosine, very good. And then derivative of the second one. -2 e to the power -2t. The -1's a constant, so that's gone. Now this would be a calculator allowed thing. So just watch. I'm going to go to y equals, and I'm going to type in the first one. Now I'm going to type x, even though that says t. It'll be our little secret. All right, and then down here, and I want you guys to just watch. I just typed in both in. Do you see that? Now, if you don't do the window, you won't get the correct number of answers. So I'm going to go to window. Now that's all messed up anyway. What did it say our window was? All right, 0 to 10. It doesn't really matter what the y's are. I usually start with -10 to 10 for standard. You can always play with that later, but this needs to be 0 to 10. Now, all we're going to do is count how many intersections there are. Wait, something is wrong there. Am I in the wrong mode? Hold on. I'm in degrees. Let me change it to radians. Rookie mistake. There we go. How did I know it was wrong though? Let's talk about that. Yeah, well, cosine should be a wave and it didn't wave. So, okay. Now this is also a little bit tricky. We have that wave. Do you see how this exponential one comes up like this? Do you see how it disappears?
Yeah.
It's because it's getting closer and closer to that asymptote. So let me draw it. We have this graph waving. I'm going to like kind of dramatize this. And then the other one comes up like this and it looks like it disappears, but it's going to keep on going. So how many times do they intersect? If this keeps going along the axis, 1, 2, 3. Do you see how it's going to keep going? Like now mine's not like accurate. I just did a little doodle, but this graph is going to keep on coasting along that axis. So 1, 2, 3. So 3 is your answer.
Wait, so are we counting the number of times the 2 lines
Intersect, yes.
or-
And it's because it said, how many values do they have the same velocity? So we found the velocities, we looked at the graphs, and we just counted how many times they intersect, because that's when they're equal. Go ahead.
So for this kind of five, is there V1 and would that be the multiplication? Or is there no multiplication?
They don't really ask usually for something like that for how many values, because what would you say? That's how many times they intersect. They don't usually ask for it on something like that. They want justifications on like speeding up, slowing down. That's a big one. And stuff like that. All right, displacement. That's another word for velocity. Do you want to go ahead and put that there? Velocity. Or, oh, I'm sorry. I'm brain dead. Position, I apologize. Displacement, because it's where you started versus where you ended up. So it's where you are. It's just position. I apologize. In feet, which that's the huge clue. Because if it was velocity, it would be what? Instead of feet, it would be feet per whatever it is. Okay. Is given by S equals T cubed over 6. You know what? Can I go ahead and write that? I would write that as 1/6 T cubed. That's a personal preference, but does anyone agree? Like, I don't know. I like that as a coefficient, so it's not like a mushed together fraction. All right, and then time is in seconds. So we have feet and we have seconds. Find the average velocity. That means slope. All right, so we're gonna plug in 0 and we're gonna plug in 1. To position. If you're like, Miss Cole, why don't we use velocity? It says average velocity. When you take a velocity, that becomes instantaneous rate of change. Remember Alice going for a walk, okay? So if you plug 0 into this, you get 0, which is kind of nice. If you plug in 1, you get 1/6. And then you slope them. So it would be 1/6 minus 0 over 1 minus 0, which I would usually say do nothing, but that comes out to a 6. So, you know. And then units. Feet per second. Whether it's an average rate of change or an instantaneous rate of change, I get that they're different. It was still a rate of change, so something per something. Now, instantaneous velocity means you need to actually get a velocity equation. That's where you do calculus, is like, let's actually take a derivative. And this is where I think it's useful to have that written as a 1/6 out front. If you bring this 3 down, it becomes 3/6. Good. 1/2 T squared, good. And then we're gonna plug in 1, which would give you 1/2 feet per second.